Hi everyone, this is Sunny Kumar from IIT VHU and welcome to my channel Code with Sunny. And today I am going to discuss the problem Pacific Atlantic water flow. Index number is 417 and the problem is of medium type of Leetcode. Okay, so let's discuss the problem now. We have been given a m into n matrix of non-negative integers, that is the integers numbers, that is the cell values are greater than equal to 0, representing the height of each unit cell in a continent. The Pacific Ocean okay, so touches the left and top edges of the matrix. So basically left and top edges are the filled with the water, or you can say the Pacific Oceans, okay, and the Atlantic cell ocean touches the right and the bottom edges, okay, and water can only flow in four directions: up, down, left, or right, from a cell to another one with height equal or lower. Okay, so say, let's say some particular cell has a height of 5, then it can only flow to the neighboring cells, that is up, down, left, or right, only if the height difference is what, so you can say the current cell minus the neighboring cell must be greater than or equal to 0. Okay, find the list of grid coordinates where water can flow to both the Pacific Ocean and the Atlantic Ocean. Okay, we have to return those coordinates of the cell from which the water can go to both Pacific as well for Atlantic Ocean. Okay, we have to return the list of grid coordinates such that is the cell coordinates of those cells that can satisfy this condition. Okay, there is a note also given. The order of return grid coordinate doesn't matter. The m and n are less than 150. It signifies that we can use a breadth first search approach also, because the m and n are very less 150. And if we do like 150 into 150 at maximum, so it would be like 225 into 00. Yes, it is fast. Okay. So here is the example. Okay, so how we can understand this question in the most efficient way and what should be the best solution for this problem? Let's understand this with the help of the example. So let's move further. So I have taken basically a simple grid. You can say these are the, you can say the number of rows, and here are the number of columns. Okay. Okay. I can say that is the Pacific Oceans are like filled with these cells and these cells and these cells, these cells and these cells, and this one, and this one, and this one. That's the initial top edges, topmost cells and the leftmost, and the Atlantic ones are like this one, this one, this one, this one, this one. That is rightmost and the bottommost. Okay, and we need to find what are the number of cell coordinates. That is, let's suppose I can say I am going to fix this cell 5, that is cell with value 5. If we are going to check if this cell is if I'm going to pour some water on this cell, if this cell that is let's say I have poured some water in this cell, and if it is possible that this water can reach to Pacific Ocean or Atlantic Ocean, that is if this water can reach to both the oceans, I can say yes, my coordinates of this cell will be included in our answer. So let's check it out if this is possible or not. Yes, 5 can reach to 3 because the cell difference, that is 5 minus 3, is greater than equal to 0, and 3 can also reach to 1. Yes, we can see I can reach the Atlantic Ocean, that is the rightmost you can say the rightmost corner of the matrix, or you can say if I reach from the bottommost corner of the matrix, yes, I can also say I can reach the Atlantic Ocean, that is you can see 5, 1 and 1 also. And let's check it out if I can reach to Pacific Ocean or not. Yes, 5 to 4 and again 4 to 2. Yes, I can reach Pacific Ocean, so this must be included in our answer, that is the coordinate of this cell. Okay, and let's check it out for the other cells, like let's say I'm going to check for this one 7. Yeah, if I can if I'm going to pour some water on this cell, can I reach to 6, or you can say Pacific Ocean or the Atlantic Ocean? Yes, I can reach, because 7 is greater than equal to 6. I can reach to Atlantic one also. So these coordinates must be included in our answer. So what should be the approach? So it is fine. Yes, everyone can understand this question easily. Then what should be the approach to solve this problem efficiently? We can have a very much a brute force approach, like go to the each of the cells and check it out by performing, or you can say do the recursion like stuff, that is go to the next cell and then go to the next cell and check it out. Yes, if I have reached any of one of the cells of Atlantic Ocean or the Pacific Ocean, if it is yes, I can do. But there must be an efficient solution na? So the best way to solve this problem is just push all the coordinates of the Pacific Ocean cells or the Atlantic Ocean cells into some queue. Okay, so you can see like okay, so if I am going to move, that is for a current cell, you can see that I have selected like 5. I can move to 5 to 3 and go for 3 to 1, and I have reached the Atlantic one. So if I am going to think in a reverse manner, that is, can I go from Atlantic Ocean to the cell with 5? If I am going to think like that, that is from 1 to 3, and then from 3 to 5, then it will be easy for me. That is how it will be easy for me to get the answer efficiently, because I have already pushed all the cells of the Atlantic Ocean into my queue, and then check it out if going to the neighboring cell is that is going to the neighboring cell is good or not. That is, if my current cell value is going to be like less than or equal to my neighboring cell value, then I can say water can reach from the neighboring cell to my current cell. You can see also, that is, let's say I have the case like 4, and my Atlantic Ocean has a cell value with again 4. You can see water can reach from this one to this one, or you can say inversely, water can also, you can say neighboring cell value, if neighboring cell value has value greater than or equal to my current cell value, that is of Atlantic Ocean, yes, I can say water can reach from neighboring cell to my current cell. So I am going to do like in a reverse manner. Start with the cells width of Atlantic Oceans or the Pacific Oceans, and check for the neighboring cells. If the neighboring cells has the value greater than or equal to my current cell, just push that elements into my queue again. That is, if I can say yes, I can reach from 1 to 3 to 1, then I can also say I can reach from that is 3 is greater than or equal to 1. Then I am going to push 3 into my queue, and I am going to check again if my topmost element of the queue has encountered this cell, then I am going to check if my neighbors of 3, that is 5, if I can reach, if water can come from 5 to 3. By how can we check that? Just check the cell, and that is the neighboring cell 5 is greater than or equal to 3. Yes, it is good. Yes, I can say 5. We can also reach 5 from 3, that is, sorry, from 3 to from I can say from 5 to 3, that is, water can flow from 5 to 3 also. Okay, so this is fine. So basically I am going to just push all the Pacific Ocean cells and the Atlantic Ocean cells separately. Okay, so first I am going to do for the Pacific Ocean or the Atlantic Ocean, and check what are the cells we can reach from Pacific Ocean to the Atlantic Ocean by checking that if current cell value is less than or equal to the neighboring cell, I can go to the current neighboring cells. Okay, so inversely, it is like water is flowing from the neighboring cell to the current cell, because the neighboring cell has a value greater than or equal to my current cell. Okay, so just do that, and like a BFS approach. Okay, if this is if the set condition is satisfying, just push the coordinate cell into again my queue, and just perform repeatedly again the same operation, checking the neighboring cells. And at last you will like exhausted with all the coordinate cells, and you have a Boolean matrix consisting of what are the cells that are being visited from the Pacific Ocean to like all the cells. Okay, so inversely you can say the water can also reach from all the cells to the Pacific Ocean. Okay, because I have checked the condition. So this was the main basic approach to solve this problem efficiently. Okay, rather than going for each of the cells and checking all the neighbors. Okay, so let's move further to the coding part. Okay, so let's code it out as fast as possible. So let me define first something that I need repeatedly in my program. So I need to define f as first, and I need to define s as second, and I need to define my PII as pair int comma int, because I need to take that in repeatedly in queue related problems, I think. Okay, so let's define my answer first, vector of vector int. Okay, because answer I need to return the answer in this format, and let's define it as answer. And now let's take as m as number of columns of the matrix, that is matrix dot size. And okay, so if m is going to be 0, just return answer. So I'm writing here base cases. Okay, and if that is done, then again check if n is going to be 0, then again you can return the answer. Now here my base case is done. Okay, and what is n here? I need to write that also, matrix of 0 dot size. Okay, okay, m is matrix dot size and n is matrix of 0 dot size. Okay, done. Now I need to define two Boolean matrices, Pacific questions and for Atlantic questions, like vector of vector bool, and it should be like Pacific of m comma vector of bool, and it should be like n comma false by default. Okay, so just copied it down and just paste it over here and just change some name of this Boolean matrix as Atlantic. Okay, so let's define a queue here for pushing the elements for performing the operations for Pacific questions and for Atlantic questions. So let's name it as q and q the queue of pairs, and let's write it down for do for Pacific question and just iterate it down for I to m, that is for number of rows first, that is I int I equal to 0, I less than m and I plus plus. Okay, so I need to push two pairs, two elements, that is the cell coordinates q dot push, and it would be like I comma 0, and also Pacific of I and 0 will become as true because it is initialized as 0. Now I need to add for the column part also. So for int I equal to 0 and I less than n and I plus plus. And for in this case I need to push the pair like q dot push, and it would be like 0 comma I because I am always in the first row, and let's Pacific of 0 and I will become as true. Okay, so this was the part for the Pacific one. So if I'm done with this, I need to call, let's say I am calling get answer function, that is performing the BFS, get answer by BFS, that is the Boolean matrix, filled Boolean matrix of Pacific one. So let's pass the parameters as number of rows, number of columns, and I need Q also, and I need Pacific also, and I need the matrix also as obvious. Okay, so if it is done, I need to do for the Atlantic one also. So let's go, why not copy this that and paste it down here and change some variables, because entire code will be almost same. Atlantic I'm going to write. Okay, Atlantic one, and again for this part also I need to write I less than m and I plus plus, and I need to change the only the coordinates also, that it would be like I comma n minus 1, and here also I comma n minus 1, and this is for Atlantic one na? So I'm going to do that for Atlantic one. Now again I need to iterate up to n, and I need to push the pair like m minus 1, and it would be like m minus 1 comma I, and here also I need to write m minus 1 comma I, and I need to change the variable name of the Boolean matrix Atlantic. Okay, so what is the parameter that needs to be passed here? It should be like Atlantic, and if it is done, the finally I need to check. Okay, so push the cells where water uh, can go to both the oceans. Okay, so how, what would be the answer for this case? Just iterate over the entire matrix and check it out. If Pacific of ij and Atlantic of ij is going to be equal, then our answer would be pushed for that cell, that is the coordinates of that cell, that is you can see. If okay, I need to lower down this. If Pacific of I and j and Atlantic of I and j, then it is good. Then just push back the answer. It would be like I comma j, and yes, this is sufficient. Just return the answer finally. Okay, the entire my this main code is ready, but I need to define the get answer by BFS function. So let's do that also. So let's write it down as void get answer by BFS, and I need to have the parameters like what I have passed as arguments. So I think I need to write as int_m and int_n, and again I need to define as q pii. Note that I am taking the reference because it is after doing that q will be already empty. Okay, so I have taken the q and I need to take a matrix of boolean type. So vector of vector bool, and it is like and it's a visited. Note that again I am taking the reference matrix, that is what is actually passed. I am going to operate on that only. Okay, and let's take over the grid also. That is the matrix of original set. Let's say I'm going to write vector of vector int. Okay, and I'm going to write down as and grid. Okay, okay, I think this should be fine. Okay, so let's do the queue operation, that is the breadth first search traversal. So while not equal to queue dot empty, and it should be like, okay, now I need to push up three parameters, x equals queue dot front dot first. You can write it as I have taken the short form also, int y equal to queue dot front and dot second, and just pop it out because I don't need this one again. I need to check for the four conditions. If x plus 1 is going to be less than m and still that cell is not visited, so I'm going to write if x plus 1 and y is not visited and grid of, you can say, xy is less than or equal to grid of x plus 1 and y, then I can say yes, I can go to this one, because you can see if water has to reach the Pacific Ocean or the Atlantic Ocean, we can think of rivers, as I've already said. Think of that from the Pacific Ocean or at the Atlantic Ocean, we want to reach that cell. So that coordinate, that is the current height of the cell, must be less than equal to its neighbor. Okay, it is obvious. So I need to push the pair q dot push x plus 1 comma y. Yes, it is done, and you can see I need to update the visited one also, visited of x plus 1 and y, it should be like, and I need to assign it as true. And if I'm done with this one neighbor, I can just copy this one and paste for this one and just paste 4 times. Okay, that is 1 2 3 4. Yes, I have done. Just change the conditions, like I can change to x minus 1 must be greater than equal to 0, and okay, okay, if this is, I think this is fine, because I have done x for x plus 1 and I have done for x minus 1, I have done for y plus 1, and neighboring one y plus 1 also pushed y minus 1, the xy minus x. Okay, if this is true, that's all I've done. You can done it directly. Okay, so I've reached the here. Okay, so let's I think I've done with this. Okay, so let's run this code and check it out if this is working fine or not. I have something like Pacific of ij and Atlantic of ij, undeclared identifier j. Okay, what is j over here? Line 99. Okay, I've done something mistake. Okay, so let's run the code over here. Let's say yes, it is accepted. So let's submit this code now and check it out if this is working fine or not. Yes, it is fine. So if you have any doubts, do not forget to mention in the comment section of the video, and I will ask the viewers to like this video, share this video, and do subscribe to our YouTube channel for latest updates. Thank you for watching this video.